Guys, we're about to do notes of limits. They're not that bad. Relax. Whenever you get a chance, read that. I mean, it's not. This is not. I don't think it's too much. Yeah, read that really quick. Yeah, go ahead. Read it out loud. Okay, you can stop. You can stop. All right. So the way you pronounce it, guys, you go limit as x approaches. Notice there's a little minus sign there. So whenever you see that little minus sign, it means I'm approaching that x value from the left. If you see a little plus sign, it means you're approaching that x value from the right. So that's all it means. And don't worry, we're going to practice. There's a graph here. You see that graph? That graph that is graphed is this function right here. I'm going to show you how they got that. Relax. Hopefully we remember. So here we go. I'm going to write f of x equals, and we're going to start off with going 2x squared plus 5x minus 3 over x squared minus 9. This is, hopefully you remember this from your Algebra 2 days, so it's all Algebra 2. Remember end behavior and all that good stuff? All right. The bottom is a difference of squares. So that's just going to be x plus 3, x minus 3. The top is pretty easy to factor out, and I guess I shouldn't say the word easy because easy is relative, right? The 2x squared, the only way you can get 2x squared is 2x times x. See? 2x squared. And 3, the only way you can get 3 is 1 times 3, but remember, I got to add up to 5x. So you got to put the 3 over here because 2 times 3 is 6, and 1 right there because 1 times x is 1, or 1x, and the difference between 6x and 1x is 5x. I want the larger one to be positive because it's a plus 5x, so this one has to be plus, and this one has to be minus. See, they're not that bad. Let me turn on the other AC. Hopefully that makes sense to you guys. Does that make sense? All right. Here we go. The first, do you see a factor that cancels out? Yes. What factor cancels out? Because the x plus 3 cancels out, that means you have a hole at x equals negative 3. Do you guys remember that? Yeah. Sometimes there's a technical term for it. A hole is the same thing as a removable discontinuity. You have to zero out the factor. So x plus 3 equals 0, so x equals negative 3. I guess you could also think of it like this, miss. Where are you not defined? Whenever the denominator is 0, so x equals negative 3. Does that make sense? Okay. And now this one does not cancel out. So at x equals 3, you must have a vertical asymptote. Do you remember that? Okay. If you, whatever remaining factors you have in the denominator, if you zero them out, can you divide by 0? No, you can't divide by 0. If you divide by 0, you win the Nobel Prize because you can't divide by 0. So wherever you get a 0 in the denominator, that's a vertical asymptote. Now, child, what about this one, a negative 3? Well, these factors canceled out, so I have a hole at negative 3. Hey, that's a demerit. That's not a demerit. I'm kidding. All right. How do you find the y value of the hole? Well, I already know I have a hole at negative 3. So all you got to do is insert negative 3 into the remaining factors. So I'm going to go y value of hole. You can also say removable discontinuity if you don't like saying the word hole there. Is, let's see, 2 times negative 3 minus 1 divided by negative 3 minus 3. 2 times negative 3 is negative 6 minus 1 is negative 7. So negative 7 divided by negative 6. What's negative divided by negative? And look, 7, 6. Look what it tells you right here. After it says the graph to the right is this function. The coordinates of the hole in this graph are So this hole that you see right there, that's -3, 7, 6. This vertical line that you see right here, that's your x equals 3.
So are we looking for the limits or are we looking for the hole?
Oh, we haven't even talked about limits yet, so don't worry. We're just talking about how we got all these little features of the graph. What's up? Oh, okay. All right. End behavior. Look at this dashed line at y equals 2. Do you guys remember called end behavior? Sometimes they abbreviate it with EB. The end behavior of this function, 2x squared plus 5x minus 3 over x squared minus 9. The end behavior is, bless you. Oh, that was a good one. I bet you feel amazing. The end behavior is 2x squared over x squared. What cancels out? So 2. That's, I did the end behavior. The end behavior, I guess, did you guys remember end behavior from algebra 2? I guess, okay. If you spit in the ocean, does the ocean rise? No. So in the numerator, the ocean is 2x squared, because we're talking about large numbers of x. And the 5x minus 3 is spit. No, for real. In the denominator, what's the ocean? The x squared, and the 9 is spit.
So we just don't include that?
No, because it's end behavior. As if you spit in the ocean, does the ocean rise? No, it's insignificant as long as x is approaching a big number. So 2x squared over x squared, what cancels out? And you just have 2. That's the end behavior. Look, see? That's the end behavior. See how I'm approaching positive infinity? That's what the y value is going to be approaching as that's only positive or negative. See? Negative infinity. If I approach negative infinity, I'm also approaching y equals 2. If I see that we're having troubles with end behavior, we will do a full-blown Algebra 2 lesson. But I hope that you can understand that little piece. Does that make sense? Okay. Don't worry. We'll talk more about limits on Wednesday. Like, we'll go hardcore into it. All right. So let's go to the next page. You got it? All right. Hopefully you've seen this notation before. This means as x approaches negative infinity. So that's that same graph. As x approaches negative infinity, look at this value right there. I'm going negative infinity. The f of x is approaching a specific number. F of x is the y value. What y value am I approaching as x approaches negative infinity? 2. Put in 2 right there. Do you ever cross that line? No. It is possible to cross horizontal asymptotes. That one is. Vertical asymptotes you never cross. It is possible to cross horizontal asymptotes. In this case, we don't. That's my end behavior. My end behavior is 2. How do you do the limit notation? It shouldn't say calculus. It should say just limit notation because it's part of Precal. Limit notation is limit as x approaches negative infinity. That's how you say it. And it needs to have an argument. You can't leave it alone. So limit of f of x as x approaches negative infinity. And it equals 2. That's how you say it. Not bad, right?
I have a question.
Yes, ask.
So, at the beginning you said that if it had the little negative or positive sign, like it would mean if we were like left to right.
Yeah, upper right-hand corner.
We use that here?
No, you're approaching left forever. You're not approaching from the left, you're just approaching to the left. Okay. As x approaches infinity to the graph of f of x, so x is getting larger and larger, what y value am I approaching? 2. Limit as x approaches infinity of the function f of x is equal to 2. You can also write out the whole function if you wanted to, but it's easier to just do that. Are we still okay? Oh, all right. Okay. All right, here we go. Ready, Dulce? I was about to call you Dolce. As x approaches -3, look what it says from the what? The graph of f of x. So here it is. Here's -3, and I'm approaching from the left. What y value is that? I don't know. There it is. -3, comma. That's where the hole's at. And that's what I'm approaching. I'm approaching negative 3 from the left. So, yes, 7, 6. I'm approaching 7, 6. We don't care about continuity with limits. So you're going to say limit as x approaches negative 3, and then I got to use a little symbol because I'm approaching from the left. So what do I put? A little minus sign on the upper right-hand corner. And everyone's yawning today. Demerits for everyone. Equals 7, 6. No, I know. It's been a long 3 weeks. Limit, I've been up since I went to Whataburger at 4 in the morning. That's just the way I am. I can't help it. I got the mushroom one. Yeah. As x approaches negative 3 from the right, I'll show you receipts in case you don't believe me. I have it on my little phone. As x approaches negative 3 from the right, the graph of f of x, okay, so here it is. I'm looking at negative 3. I'm approaching from the right. What is that y value? 7 over 6. It didn't change in this one. Depends on the curve. Sometimes you got to do the Lindsay Lohan. You don't know what I'm talking about? Remember Mean Girls? When Lindsay Lohan is up on the board and she's like talking mentally into herself, and then she's like, the limit does not exist.
Oh, yeah.
Yeah, that's from that. Limit as x approaches negative 3 from the right-hand side of f of x equals 7, 6. Okay, we're not doing the Lindsay right now. Check it out. This one, as x approaches negative 3, it doesn't say from the left or from the right. So we got to check from the left and from the right, does it approach the same y value? Yes. So we're just going to say this has to equal 7, 6. Because both of them match. Limit as x approaches negative 3 of this function equals 7, 6. Yes. Then you do the Lindsay Lohan. You say the limit does not exist.
Okay. And then for this one, like put any sign, right?
Yeah, don't put any sign because it just says limit as approaching negative 3.
Oh, no, when it's coming from the right, we'll put the plus to indicate that's coming from the...
All right, this one. As x approaches 3 from the left. Okay, here's 3, and I'm approaching from the left. If I'm approaching 3 from the left, what's my y value? Positive or negative? Negative. I'm going down forever. So you're going to put negative infinity. And I know that you shouldn't put an equal sign for infinity because it's not something that you equal. But Delta Math has that habit of they also say equals infinity. So I'm going to be okay for now. But when you guys get to calculus, we'll be more specific. If you talk to a professor, they're going to tell you, what? You can't equal negative infinity. You can also say does not exist, and that's fine, but we'll talk about technicalities later on. Go on the next page. Continued, as x approaches 3 from the right, the graph of f of x. Okay, well, let me go to the graph. Here's 3. Here's x equals 3. Yep, as I approach 3 from the right, I'm approaching positive infinity. So limit as x approaches 3 from the right of f of x equals positive infinity. That's this. How come you guys didn't tell me that I don't put a minus sign on the other one? There it is. Put the minus. Did you put a minus on yours? No. Top right hand corner. It's coming from the left. It says from the left. What's up?
So now, since it's gonna be like just approaching 3, right? Not from the left or from the right. How would we do that?
Well, we're about to do it. You're one question ahead of me, miss. As x approaches 3, the graph of f of x. All right, look. From the left, it was negative infinity. From the right, it was positive infinity. Am I approaching the same behavior? No. So now it's okay to do the Lindsay Lohan. If you remember, what are we going to say? The limit does not exist. So you're going to say does not exist. No, because they're approaching two different values. They have to approach the same value or the same behavior. Write what down?
Can you like
Okay. Since limit as x approaches 3 from the left of f of x does not equal limit as x approaches 3 from the right of f of x. See? Using math symbol. That means the left does not equal the right. Since limit as x approaches 3 from the left of f of x does not equal limit as x approaches 3 from the right of f of x. So they're not the same, so the limit does not exist. Yay or nay? Yeah, I know, Mondays are always tough. Let's see what it says. A function f of x has a limit as x approaches c if and only if the right hand and left hand limits of c exist and are equal. That's what we just said. So if the left side equals the right side, then you can just write it like that, and that equals whatever number the left and the right is. Cool or not cool? Yeah. Look, I bet you're going to be able to do this like a champ. Ready, Kyle? Yeah. No, hey, you're good. You're good. So how do I read this statement, miss? Yeah. So here's -1. Oh, come on, Miss Cruz. So here's -1. If I approach -1 from the right, what is this y value? 1. 1. There it is. Done. 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 What do you think, Morales? All right. Let's go to letter B. Limit as x approaches 1 from what side? So here I am. I'm approaching 1 from the left. What do you think, Morales? What y value am I approaching? 2. 2. I'm approaching 2. Limit as x approaches 1 from the right. What do you think, Deanan? 1. If Juan was here, I'd say Juan, but he's not here. He's no longer with us. He's still alive. He's just not. He's a boy, you know. So he's. I think, yeah, Juan. Yeah, I used to make fun of him so much. It was so. Now that I think about it, he could take it, but he was a football player. He was fine. All right. Perfect. Why? Tell us why it does not exist, miss. They're not approaching the same value. If I approach 1 from the left, it's 2. If I approach 1 from the right, it's 1. So because I'm approaching 1 here and they're 2 different values, this one does not exist. Yes, that's why we're doing it. I think there was a free response that literally said, write it in limit notation. Remember that question? So that's why we're doing limits right now. But don't worry, we're just going to do simple limits. Limit as x approaches 2. If I approach 2 from the left, if I approach 2 from the right, what y value am I approaching? 1. Limit as x approaches 3 from the left. What y value? 1. Does letter G have the word limit? No, it just wants you to evaluate f of 2. What's f of 2? 2, not 1. There's a hole at 1. There's a hole at 1. It's all it says. Sometimes they do piecewise functions. When x is 2, what's the y value for this function? Well, it's 2 because there's a dot there. Yeah, you're undefined right there. That's a hole. That's a hole. All right. Let's go to the next. See, they're not so bad. So here's how it's going to look for you guys. Let's see. Limit as x approaches 3. What does that little symbol mean? From the left. So here's 3. I'm approaching from the left. What's the y value? 1. 3, not -3. 3. 3. What's up? It would be undefined. So we're not there yet, though. You're getting ahead, miss. Limit as x approaches 3 from the right. What is it? No. 3. You're approaching from the right. So here it is. Boom, 3. Do you see how we're doing it? Okay. What's the limit as x approaches 3? Does not exist. This is for limits. Does not exist. The limit does not exist. But this one, notice it says f of 3. I'm going to look at x equals 3. Do I see a point or a solid curve in that x equals 3? So you're going to say undefined. I'm approaching 3 from the left. So if I approach 3 from the left, look at the y value. 1. This says 3 from the right. So I'm approaching 3 from the right. Look at the y value. 3. See?
Because what I was doing is I was just going straight with that. So you have to follow the path.
Yeah, you got to follow the curve.
Okay. So I was just going like that.
No, there's nothing. You know what I mean? You got to follow the curve, Morales. Follow the curve, the function. We're okay? Okay. All right. Check it out. Relax. Don't get confused. Oh, ask me questions, guys. Ask me. Dime. Dime.
I'm kind of confused, like, on how you found, like, the limit does not exist.
I got you, miss. I got you. If I approach from the left, the y value is 1. If I approach from the right, the y value is 3. Are they the same number? So because I'm not approaching the same y value, the limit does not exist. Let me see if I can scroll. Yeah, see, look at it's this theorem right here. In order, I guess I should have written in here. If the left side equals the right side, then the limit exists. It's L. And I guess I should have written if the left side does not equal the right side, then the limit does not exist. You know what I mean? All right. What's up? What's up, Zamora Johnson? Hit me. Oh, you're undefined because when x is 3, there is no solid point anywhere. That's a whole. There is no y value that's defined when x is 3. Now the limit, if you approach from one side or the other, like, yeah, there's a y value you're approaching. But that doesn't say the word limit. That just says f of 3. When x is 3, there is no y value. Look, that's a hole. That's a hole. You're not defined. Now, if I were to put a hole, if I were to put a solid point right there at 3, 6, then I would say f of 3 equals 6. Or if there would have been a solid right there on that curve, then I would have said 3, 3. Or if there would have been a solid on this point, a solid point, 3, 1. But there is. Or being on the curve. You know what I mean? Like you got to be defined, and you're not defined. Yay! Yeah, keep them coming, guys. Keep them coming. All right, this one right here. Use the graph of the function f of n shown below in order to determine all values of a for which limit as x approaches a of f of x equals 0. Okay, let me show you how to do it the easy way, guys. Relax, don't freak out. This a, letter A, does not have plus or minus sign. So the only time the y value is 0 is when you're on the x-axis. So here's what I see. I see that it's 0, bam, right there. See, it's touching it. I see that it's 0. I know there's a hole, but we don't care about that hole as long as we're approaching it. I see it's 0 at x equals 2. Do you guys see that? And I know some of you are going to say, Chav, it's a 0 at 7, but that's from one side. This doesn't have a plus or a minus, so it wants from both sides. Does that make sense, guys? Okay, tell me, Houston. It has to be approaching 0 from both directions. It doesn't have a plus or a minus on the A, so from the left and the right, it has to be approaching 0.
So all the values except for -7 and 7?
At -7, it's approaching -2. -5 is 1. 2 is 1. And 8 is 1. It has to approach from both directions. I'll write it right here. Limit as x approaches -5 of this function is 0. See, if I approach -5 from the left and the right, it's 0.
Because like the hole is like doesn't have like any other line going through it, right? It's like
I'm listening.
it's no longer like it stops at where it is, right? Like that's why it's not like accepted, right?
Okay.
Because there's lines on both sides.
Yeah, that's why those are accepted like that.
Yes. The one at 7 can't be it because it's only approaching from one direction. This one doesn't have a plus or minus. See, it just says x equals a or x approaches a. So I need to approach 0 from both directions. See or no? Que sí, que no. Don't worry, I'll write it in a little bit the way it should be meant. Okay, -5, 2, and 8. So I'm going to say it wants to know what a is. So I'm going to write a equals -5, a equals 2, and a equals 8. I guess you could have just written 1a and then -5, 2, 8. Are we okay? Sorry, I tried to say it, but I started choking. All right. Chubb, I've never seen a piecewise graph before. I don't know how to do it. Yes, you do. If you have colored pens or colored pencils, this is a good place for them. I'm going to use all different types of colors to demonstrate this. Y'all ready? Let me put the grid. Let me make a grid here. Let me see, how far back do I go? Nope, I'm going to be above the x-axis all the time, it looks like. 2 minus 1, 1, 3 minus 1. Yep. All right. Here we go. Ready? I'm going to do this one in red. I'm going to circle each one. This is called a piecewise function. You don't need to sketch a graph to find these limits, but you guys are visual learners. You guys are visual, so you guys like to, I think you guys, it's easier if you see a picture. All right. All of these are linear lines except for the point at 2, 2, and, okay, don't worry, I'm going to break it down. When x is 0, the y value is 1. So put a point at 0, 1 point. I'm going to say that's 1. Does everyone see what I'm doing? I'll say it again just in case. All I'm doing, this is my domain. Yeah, all I'm doing is plugging in a 0. 0 plus 1 is 1. So my y-intercept is 1. When x is 1, what's negative 1 plus 1? 0. Notice there's no equal sign on the x equals 1 or x less than 1. So I'm going to say here's 1, and I'm going to put an open circle and connect those two. The y value is 0, not the x value. These are my x values here on the right, and on the left hand side is my y value when I plug in those x's. You know what I mean? Check it out. Look at the next one. Between 1 and 2, well, notice there's an equal sign on the 1, but between 1 and 2, the y value is always what? 1. So here we go. I'm gonna use the color green. So I'm gonna do this one in green. So when x is 1, the y value is 1. So I'm gonna put a solid circle. Job, why are you putting solid? Because there's an equal sign there. Do you guys see that? And I'm gonna go all the way to 2. I'm gonna say 2 is right here, and I'm gonna go open circle. Are we still okay? Okay. I'm gonna choose purple. The next one is just a point. When x equals 2, the y value is 2. I'm going to say 2 is like right here. So I'm going to go 2, 2, point. That's a point. Solid, nice point. All right, what's the next color? I'm going to go blue. You don't have to do blue. Just make it a different color. Or just organize your notes the way you can read it. If you don't need to change colors, then don't. All right. When x is 2, 2 minus 1 is, what's 2 minus 1? 1, so I'm right here, open circle. When x is 3, and all these are linear lines, so I'm just going to connect them. When x is 3, 3 minus 1 is 2. So I'm going to go to 3 and put a solid circle at 3, 2. And I'm just going to connect them. Let me stretch this out just a little more. There we go. And what color have I not used? I guess I can add a color. Okay, let me add a color. Pen. Oh, I'll just leave it. I'll do yellow. Oh, that is a highlighter. I'll do black. Sorry. All right, here we go. Negative 4 plus, no, 3. Negative 3 plus 5. 2. It doesn't matter. There's already a solid circle there. That's fine. Not a big deal. I did put an open circle for the black there. And then when x is 4, I'm going to say 4 is right here. When x is 4, negative 4 plus 5. 1. That's a solid circle. And then connect them. Say it again. It's open, but the blue one is solid, so that's why it doesn't. The blue one is solid, so that's why it doesn't look like it's open. All right, there it is. Okay, now we're ready. Here we go. Limit as x approaches 0 from what direction? The right. What's that y value? What's the y value? Limit as x approaches 0 from the right is 1. Okay. I'm going left to right, guys. I'm in this one now. Limit as x approaches 1 from the left. What is it? 0. You're looking at the y value, guys. You're looking at the y value. The y value. Limit as x approaches 1 from the right. 1. Limit as x approaches 1. D and E does not exist. You guys are making up your own acronyms. Limit as x approaches 2 from the left. 1. Limit as x approaches 2 from the right. 1. Limit as x approaches 2. 1. They both match from the left and the right, so it's 1. You can also visually see it in the graph as well. Are we okay? Right. Limit as x approaches 3 from the left. 2. Limit as x approaches 3 from the right. 2. Limit as x approaches 3. 2. Good job. Limit as x approaches 4 from the left. 1. Uh-oh, this one doesn't say limit. This one just says f of 2. 2, wherever it's defined. It's that dot right up here. That dot is 2, 2. Cool or not cool? All right. Now you guys give it a shot. See if you guys can figure this one out. Take a minute. It's not even that bad, guys. Try it. Oh, it's a quadratic. I can't do it. Guys, the vertex is on the y-axis. There are a lot. Negative 2 squared is 4 plus 1 is 5. The vertex is on the y-axis at 0, 1. Then draw a parabola. A negative 2, you're at 5. And a 2, you're at 5. Chav, how'd you find that? Negative 2 squared plus 1. Right? I'll start drawing it for you guys. But guys, come on. You got to be able to do some of these. No. You're going to have to. You're going to have to. So look. This one right here, I'm drawing it in green. Here's 1. And I'm going to say here's negative 2. And I'm going to say here's 2. And it's going to go something like this. There's an equal sign and not an equal sign. So solid. It's going to be a parabola. Open. Okay.
How do you know that it has to go, like, how do you know it's moving?
It's a parabola, x squared plus 1. Keep asking. I don't know what. Yeah, the y-intercept is 1, right? X squared plus 1, it just moves x squared up 1. Vertical transformation. We all took algebra 2, right? What, keep hitting me, guys. Hit me. What's the next one? What's the next question? What's the next question, Lazardi?
I think my question is, so like, how are you finding exactly where to put the point? Like, I see it every time. I know I start with calculus, but then like, I see.
I just know that the function x squared is a parabola going to the origin, and that plus 1 just moves the parabola up 1.
So for this one, it would be
At x equals 2, the y output is 1. So I have a point. Let's see, what color am I going to use? I'll use purple. 2, 1 point right there. That's this one right here. That's the purple one. And then I'll do the green one. I'll do this one in green. Between 2 and 8, the output is always 5. There's not an equal sign, so open circle. I'm going to say 5 is like right here. Oh, 8. Sorry. 8. What's a what? That's 5. Write it with limit notation, guys. So help me write it. How do I write it? There it is. Limit as x approaches 2 of the function f of x equals 5. Because if I approach from the left, it's 5. If I approach from the right, it is also 5. All right, guys, that's it. We're done. Take care of the delta, and let me know where we have issues.